Welcome to my lecture video. My name is Cosmo Brian, student from Maseno University, taking medical biotechnology with IT. So today I would like to zoom into the pancreas, specifically glucagon. I like the word gone. So this glucagon, we would like to zoom into the pancreas. So straight away, the pancreas, they say to be an heterocrine. Heterocrine. What does it mean by saying heterocrine? You remember in high school what we used to say heterozygous. So, by the way, so let's zoom into the heterocrine. What does it mean to be an heterocrine? And heterocrine, that means that it's made up of two tissues. That is the endocrine tissue and the exocrine tissue. But today we want to measure here the endocrine tissue. So this endocrine tissue is made up of two types of cells. You have the alpha cells, and also the beta cells. So the alpha cells normally secrete or they release glucagon. Remember, alpha they release insulin hormone. Now glucagon is normally released in response to what we call hypoglycemia, and this one's released in response to hyperglycemia. Hyperglycemia. So these hormones are antagonistic. They are just antagonistic. I don't have to explain for you what means by the word antagonistic. So the normal glucose in the bloodstream, it should be around 80 to 120 milligrams per dl. So low concentration of this or below this, it's referred to as hypoglycemia, and above this one is referred to as a hyperglycemia. So these two hormones normally regulate blood in the bloodstream. But let me try to explain for you much deeper. I apologize for the video because at the same time I'm recording, speaking, writing, those things. So don't worry, this is from the CCK, cholecystokinin, and also from secretin, the GIT, and all this is for norepinephrine, and also norepinephrine and epinephrine, also the sympathetic nervous system. So here we have the alpha cell. This is the DNA. Also we have some transporters here. GLUT, they are called GLUT1, but in the other side of insulin they are called GLUT4. Here we have some potassium channel, and also here we have calcium channel that's sensitive to voltage. It's called voltage gated channel. So okay, let me just explain for you briefly. So glucose enters through the GLUT channel. After entering into the GLUT channel, normally glucose, it is just converted glucose pyruvate. Then pyruvate enters. This is a mitochondria, forms acetyl-CoA. Then acetyl-CoA enters into the Krebs cycle. The Krebs cycle leads to production of ATP. Now ATP because this glucose level is low, meaning that there's low pyruvate, low ATP. Now this ATP binds to these potassium channels. After binding these potassium channels, there is low accumulation of potassium channels in the cell, in this cell, meaning that it doesn't cause depolarization of the cell membrane. And so this causes this calcium these calcium channels to open and let in, causing the intrusion of calcium. Just leave it there. We come to this. Now, this is the alpha cell. The alpha cell, there is a DNA in the alpha cell. So now in this alpha cell, this DNA undergoes transcription, forms mRNA. This mRNA is taken to the rough endoplasmic reticulum. Remember, in the rough endoplasmic reticulum, there are ribosomes. Now, these ribosomes synthesize this protein. After synthesization of this protein, leads to the formation of pro-glucagon. This pro-glucagon is then taken to the Golgi apparatus, where it undergoes screening, processing, and after all of those processes, it leads to formation of vesicles, where this glucagon is just packed in. This glucagon is just packed in. I told you that this load, because this potassium channel doesn't cause depolarization because it is in low concentration, this intrusion of calcium channels causes these vesicles of glucagon to move close to the cell membrane. And after moving close to the cell membrane, fuse of the cell membrane, leading to their rupture. After they rupture, now they release glucagon to the blood. Glucagon to the bloodstream. I think you remember this during the nerve transmission processes, acetylcholine, or now the calcium, when the calcium they are released, they cause these vesicles that houses or with this acetylcholine to move close to the cell membrane, they rupture, and then they release acetylcholine to allow depolarization of the adjacent membrane. Same applies to this one. Now, after the release of this down, that's how it enters into the bloodstream. Thank you.